My latest project on my workbench under the stairs is based on something I said in a previous video. According to Google's YouTube analytics, apparently only 6 people watched that video, but I will post a link in the corner and in the description, so maybe some more people can watch it. So in that video, I said that we need to start fixing our stuff again. And I kind of got thinking about how we've become a disposable culture. Anything that breaks down, throw it away, replace it cheap. Well, replacing things now is really not that cheap. So, and that's why we got to get back to fixing our stuff. I mean, and that's what we did up until about the mid 1980s. And if we couldn't fix it, we could find someone who did. You know, mechanics and technicians, tailors, people who fix stuff, they made good wages. They built our communities and they built our countries. And anybody who holds elected office or seeking elected office, they can't make our countries great again. It's you and me. And this is why I picked this Bionaire window fan. It's got, I believe, a simple problem. So it's going to be a simple fix. So the complaint is one of the fan units spins at regular speed. The middle one it spins very slowly, and the right one doesn't spin at all. So I'm thinking it could be a simple electrical problem. It could even be, I'm hoping it's not the fan motor's burning out, or maybe it's just dirty and needs new lubrication, but we'll check and see. Turning on the center fan unit, it spins and looks like it's almost full speed. Then switching over. Okay, that's noisy, so that's obviously a fan bearing that needs lubrication. And all three, and right one doesn't spin. So let's start taking this apart and let's see what we can do with it. So starting with the left hand, the fan turns relatively smooth and relatively freely. The middle, it's a little tight, doesn't spin quite so free, but this run on the right, this doesn't spin well at all. So the next thing we need to do, we just have to take the plastic fan blades from off of each of the motor mounts. And to do that, we have to take these metal clips off and so it'll just take a flat blade screwdriver and very carefully, and making sure the metal clips don't fly away because they'll never come back if they do. Just pry them up and just one after another. And then the fan blade should just pop right off. Yep, just takes a little bit of pulling, but it is coming up. That one was a little easier. And last but not least, and of course, more screws to take out and another cover to remove. So a little bit of basics on these small AC motors. It has two parts. The stator, which is going to be this big frame that, as the name gives away, it remains stationary, and then right in the very middle, the section that turns, or the section that rotates, is logically called the rotor. And in between, in the middle, there's bearings to help reduce friction, and sometimes they do need lubrication. So we just need to dismantle, and let's see if we can just clean it and lubricate it to get it working. So we first start by taking apart the screws on the one side. And I'll just call this the top side bearing. So now there might just be the two screws that hold the whole works together. And that's what it feels like. There we go. So next, there we go. The first bearing comes out. The rest of the rotor comes out. And then the backside bearing comes out. So the first thing I'm going to use to clean and lubricate the guts of this first motor is some regular common household WD-40. And I'm just going to apply some to a paper towel, and then just clean the shaft just like that. And then the bottom that in the other winding, and looks pretty grungy. Looking pretty grungy. So next comes the actual bearings. And for that, I'm just going to use some regular hardware store 3-in-1 oil. And there's a felt wick right in the inside, which is probably as dry as a popcorn fart in the desert, and is probably the reason why this thing kind of slowed down and stopped working. So I'm just going to squeeze a little bit to let it soak in, and it's actually started soaking in quite quickly, so it probably means these are really quite dry. And we'll just let those sit for a while to let the oil soak into the wick. Now that a few minutes has elapsed to let the oil soak into the wick, I'm going to reassemble the motor. So I'm going to start with the bottom bearing, and just put the rotor on. Then I'll put the stator on next. There we go. And it not feel like it. So unless, let's see here. Now we kind of got to figure out what to do with these wires. Now that there we go. And now we put the other bearing back together. And so then we just screw it back in together, and okay, now the motor's back together. Giving it a spin, it definitely turns a lot more freely. So I'm hoping that's all it needs. And then I just rethread the wires back into the back into the guides and just like so. And now, okay. So I'm going to proceed with the other motors. So after applying the oil to the dried out felt wick, it obviously goes to show that they're only going to apply enough oil to create a motor that provides a functioning product. And if it gums up, so what? They'll just come back and keep buying another one next year. But with a um, little bit of knowledge, you can avoid this, getting off this financial merry-go-round. So, and in today's world where everything keeps getting more and more expensive, this is going to be a skill that's going to be not just useful but essential in years to come. So as it may seem that we're kind of falling behind and we've kind of handed away manufacturing to, the less fortunate nations of the world, and that's not coming back. You can't recoup the costs. But the one thing you can do, learn to fix your stuff and just demand consumer products that are easily fixable. And that's one thing, and the one thing called right to repair, that's going to do a lot more to make our countries great again than whatever bluster comes out of, the president or a prime minister or whoever it is in office. So now I'll just get off my soapbox and I'll just do the third and final motor on off camera. And I'll show you the outcome. Okay, so after getting the fan back together, now I do have this plugged in, so which is not normally a wise thing to do, but middle fan spins at full speed. Both, now I got both the left and middle spinning at full speed, but I still can't get anything on out of this right hand motor. And I'm not getting why it's not doing anything. I can spin it, but it doesn't do anything. So I guess we'll be doing some electrical troubleshooting after all. To try to troubleshoot any potential electrical fault that's keeping this right motor from spinning, I'm going to use my multimeter to check for continuity across the wiring, starting at the plug, going right to the motor. Now the power switch for this fan actually gives me a shortcut. In the first setting, only the middle fan spins. In the second mode, the left and the right fan motors spin. So, by checking resistance from the first mode to the second, I can figure out if it's electrically open. If I go from mode 1 to mode 2 with the same resistance, that will tell me that I have an open in the circuit. Now, for basic Ohm's law, for you'll have, the motors will have a similar resistance, but when you connect two in parallel, you'll have half the resistance. So if I switch and the resistance doesn't change, that proves that the circuit is open to the third fan motor. So with my multimeter connected across the prongs of the power outlet, I've got my multimeter set up, so I will start by turning on the first setting, which is just the center fan motor, and that gives us roughly 136 ohms. So when I switch to the second mode, which is the two side fan motors, and let's see what happens on the resistance. It says 134, which is roughly the same. So that proves that somewhere between the power switch and this motor, or even the motor itself, is open. So now to prove, I'll switch into the third mode, which is all three, and the resistance dropped down to 68 ohms. So we have proven that somewhere along in this circuit to the third fan motor, the circuit is open. In order to find out where the circuit is open, we have to check for 3 things: the motor, the switch, and the wiring in between. So I'm going to start by taking a resistance measurement across the motor. If I get a resistance measurement, I know the open is not in the motor. So in order to do this, I have my multi-liter leads, and I have a couple of sewing needles attached to the gator clip leads. And this is a trick my high school electronics teacher taught me. You can just poke into the insulation, make contact with the wire inside, and then you can take your reading. So if there's no open in the motor, it should show about the 130 ohms that you got on the other motors. So I'll just start by poking these into the wire, and should be, and yeah, 136 ohms. The motor's good, so now we can move on. Now the best place to find out where next to check the switch and the wire inside, I'm going to start at the plug. The way I'm going to go about finding where the short in the circuit is, I'm going to start at the plug, and I'm going to check the neutral side, which on a polarized plug is the wide side of the plug. So I'll just hook a clip lead to that, and then I'm going to go back, switch on the fan, and then I'm going to probe, and I have a feeling the gray wire is the neutral. I'm just going to plug in, and there we go, 0.8 ohms, which means the neutral side has continuity. So that means we now know the open in the circuit is not going to be in the cord and not on the neutral side of the line. So I'm going to come over to the switch, and I'm now going to clip onto the hot or live side, and then on the setting where all 3 fans are on, I can just clip in here. Okay, the yellow that goes to the right hand side fan, the one that's not working, it has continuity right after the switch, so that part of the switch is good. Now we know that the other 2 fans spin without problem, so those are good. So now we know the open in the circuit is between the motor and the switch on the yellow wire. So now we know what we can replace. We don't have to go any further. Okay, so now that we know that we're replacing this yellow wire, first we got to trace it out from the switch. Comes from the switch, comes through this wire nut, then divides off into two, which supplies both the left and the right motors. Now that we know that it's the right motor that's not working, we know that it's this section between the wire nut and the right motor that we have to change. But first, we got to cut out this zip tie so we know that we're going to be changing the wire that's defective and not the one that works. So now, so now we know that in this big mass that was zip tied, this upper one right here is the one that needs to be changed. So on the side on the motor, I'll just cut out this section of heat shrink tubing, and then that'll give us a good length to splice in the new section of wire. And just telling along various lengths, there's a few places where this is wire is pinched. So here, and then somewhere in here. So who knows? It could be any one of those kinks that that broke the wire. And to do my repair, I bought a spool of 16 gauge wire. It's even yellow, so it matches perfectly. I just picked that up at my local hardware store. So to begin, we're just going to cut roughly about around 4, maybe 5 centimeters from the end at the motor. And likewise, at the wire nut, we'll cut about 4 or 5 centimeters from that end too. And we'll just pull it out. So then we'll just strip off about a couple centimeters worth of the insulation. And this is a little hard to do on camera, but we just take our knife and we just cut into the insulation until we feel the actual wire on the inside. And when you feel it's weakened enough, you can just pull the insulation back and then give it a twist and a twist until the end of the insulation comes off. And then on the other side, we just do the same. We cut into the insulation until you feel the hardness of the actual wire on the inside. And we just keep cutting and cut until you start to feel it give, and then just start pulling. And there we go. Now we've got both the ends stripped, and now we just pull about the length we think we're going to need. And where the heck did the cutters go? Oh. And then cutters like that. And then we take our new length of wire and we just strip it off in the same way. About maybe 1.5 centimeters. And just keep cutting into the insulation until you feel it's going to come away from the wire. Pull and just give it a little pull, and then give it a twist, and just like this. And twisting it keeps all the wire all in one place. So now that we have the insulation from the ends of the wire stripped off, we're going to join them and solder them. So the first thing to do, we just take and we just take the stripped off portion of wire and just bend a 90-degree angle on both ends. So and then come and then on opposite sides, and just give it a twist to form a firm mechanical connection. And the next thing, we just get our soldering iron powered up and ready to go. So now for this kind of joint, it's best to use a wedge tip on your soldering iron. So I'm going to start by applying some solder to the iron and just give a nice good blob of solder to help transfer the heat. And then you just hold the tip onto the connection and just give it a few seconds on there. And then just start applying solder. And eventually it'll start flowing on into the wire. There we go. Now the solder is flowing through the heated wires. So we now have a good, strong soldered connection. Now it used to be that after you soldered your connection, you would just use electrical tape to help insulate and protect your soldered connections. However, that was years ago, and electrical tape had a nasty tendency to come apart and short circuit or shock people. So eventually it was replaced with heat shrink tubing. So I'll grab a little bit right here, and it just happens to be yellow. So I'll just grab a piece, I'd say probably about 2-3 centimeters or so. And then just apply right across the connection. So to shrink the tubing, I'm just going to use a little lighter because the flame tends to work the best. The soldering iron just can't shrink the tubing good enough, and just until it like tightens around the wire. give it a little. Here we go. Here we go, and that creates a good strong connection, which won't short circuit, won't break out. So then I'll just do the same thing on the other side off camera, just to avoid boring you. So normally operating any electrical appliance plugged in with the cover off poses serious risk, but in this case we'll just do it just to try it and just to see if we have working. Okay, and okay, there's one. Okay, so we got off, we've got the middle, we got the left, but yet when it comes to all three, it still doesn't spin. And I don't know why. So for this time, I guess we can only call it a repair attempt. So when I sat down and started editing this video, I realized something about these outer two motors. I thought they were being switched through the power switch, but they're actually not. They're actually hooked up in parallel outside of the switch. So when I was originally testing the right motor here and getting 130 ohms, it was actually 130 ohms going through this motor and nothing through this. If this would have had normal continuity, I would only have gotten 100 or 65 ohms. So what I need to do now is I'm just going to cut the wires to this right motor, and I'm just going to check its continuity. Okay. And just okay. Okay. So now I'm just going to poke into the wire here, and guess what? I'm attached right across this motor, isolated from the rest, and it's open. That motor's dead. So I guess that's where this ends as a repair video. But like every other repair attempt, we've learned something along the way. And I think that in itself has value. So until next time, with another project here on the workbench under the stairs. See you again next time. And if you liked what you saw, press like and subscribe for more. Thank you for watching. Bye-bye.